Kia ora koutou. This video is for Zachary and anyone else in 12 MCA. It's another really nice problem from Pure 1, and it's in the May 2021 paper, and I think it's paper 1-1, question 6. Now, there's a horrible way to do this question and a really easy way to do this question. I could have done this in GeoGebra with some nice graphs, but instead I'm going to try and do what I'd do if I were you sitting in exam conditions. So we've got this first curve, and we know that k is some constant, and we're told that this line here, y equals 3x minus 4, is a tangent to the curve. So we can draw roughly, but reasonably decently, y equals 3x minus 4, and there it is there. And we know that that line is a tangent to the curve. So we could have a few different situations. We don't know where it's a tangent to the curve, that's the entire point, but it could go like that. We could have a tangency situation here, or it could be an upside down parabola, and we could have something like that. But in either case, the key to this question is knowing that if it's the tangent to the curve, then if we set the y values next to each other, if we set them equal, there's only going to be one solution. And that should trigger in your brains that this is actually just a discriminant problem, kind of in slightly different guise, right? So if I've got the situation where I've got a line and I've got the parabola cuts the curve, that means I've got two solutions to the equation. And if it's a situation like this, I've got no solutions. But if it's a tangency situation, then one solution. And so all we have to do is equate those two things and then find the condition for k when the discriminant is equal to 0. So let's do that now. So the curve is 2k minus 3x squared minus kx minus k minus 2. And we want to know when that will be equal to 3x minus 4, right? Because the y values, the whole point about something being tangent to something is that the point will be, this point of tangency will be on both the line and on the curve. So all I've got to do now is turn this into a quadratic, and I'm going to do that reasonably carefully. So 2k minus 3x squared minus kx minus 3x minus k plus 2 plus 4 equals 0. Now I'm going to try and pull out the a, b, and c. So be really careful here with your signs, right? Just watch out there. B is going to be all of that. And then here I've got minus k plus 6. So I'm going to write that as minus k take away 6 equals 0. If you've been doing any work for level 2, you'll find that this is quite a lot like a kind of high merit or low excellence question in the D&D workbooks. So we've got A is equal to 2k minus 3, B is equal to the negative of k plus 3, and C is equal to negative of k minus 6. So for one solution, we need b squared minus 4ac is equal to 0. That gives me negative k plus 3 squared minus 4 times 2k minus 3 times negative of k minus 6 is equal to 0. Quickly cleaning that up gives me k squared plus 6k plus 9 plus 4 times these brackets expanded, so 2k squared minus 15k plus 18 is equal to 0. And you can see that I've got a nice quadratic coming. 9k squared here plus 6 minus 60 gives me minus 54k. And then I've got 4 18s are 72, plus 9 gives me 81, right? I'm doing this slightly faster than usual because the dog is wandering around and I don't know what she's about to do. So dividing through by 9, we get this, which is lovely because it is a perfect square. But don't go away. I want to show you the bad way, because the bad way does work and the bad way is in the mark scheme. But it's kind of a wild goose chase because you're likely to make a mistake. So that was really nice, right? We just remembered about discriminants and tangencies and all of that, and it was 5 marks for not really that much work. If we do it the other way, if we forget about what's going on with when something's a tangent, the other thing we could do is we could say, well, when it's a tangent, we know that if it's a tangent, then the slope of this line, 3x minus 4 equals y, must equal the derivative of this function, right? That's the whole point of finding the tangent to the curve. So we're going to go ahead and we're going to differentiate this line. And then we're going to set that derivative equal to 3 because we know that the gradient of 3x minus 4 is 3. And that lets me get an x value. So dy by dx here, just using the chain rule, will be 2 times 2k minus 3x minus k. And if that's equal to 3, then I can expand this, and I'll get 4k x minus 6x equals 3 plus k, giving me x into 4k minus 6 is equal to 3 plus k. So I get an x value. X is equal to 3 plus k over 4k minus 6. So we get that far, and then we go, oh, now what do we do? Well, the only thing we can really do now is to say we know that the y value will be the same in both at that point, right? So we've found the x value where it's the tangent. So we've got a parabola like this, and we've got a line like this. So now we're going to try and solve for the value of k by saying we also know that the y value is the same at that point and that point only. So what I have to do now is this. I've got 2k minus 3, and I know my x value. It's this awful thing, which is 2 into 2k minus 3. I'm going to square that, minus k times 3 plus k over 2 times 2k minus 3. That's minus kx minus k minus 2. And on the other side, that equals 3x. So 3 times 3 plus k over 2 into 2k minus 3 minus 4. Right, so this is not impossible. We can go through there and we can simplify it a wee bit. But it's going to take up quite a lot of time. So hopefully if you did try it that way, maybe you thought that you're probably not doing it in the most efficient manner. And for those of you who go on and do scholarship calculus next year, one of the tricky things is knowing when you are basically going down a wild goose chase or using a really inefficient method, and when you're just in the middle of a whole bunch of algebra that has to be done. And so in this case, if you've got to this point, you've actually done this a far, far harder way than you had to if you'd remembered the properties of discriminants and curves. If you've got any questions on this video or want more questions like this, maybe send me an email and I can try and find some for you. Thanks for watching.